Good day. In this video, I'll be discussing about method number 1, course alteration in radar plotting. To start with, we have our problem. Given our vessel is on course 350 degrees through with a speed of 14 knots. A target was observed with the following data as follows. First observed position time is at 1000 hours, bearing 035 degrees through, having a distance of 9.0 miles. Second observed position time is at 10:06 hours with the same bearing of 035 degrees true and a distance of 7.5 miles. The third observed position time is at 10:12 hours, having the same bearing of 035 degrees true with a distance of 6.0 miles. Collision has been observed to be imminent, and your course of action are as follows. Letter A. To execute course alteration when the target range drops to 5 miles, that's your RMX. Letter B. To maintain speed and let the target pass ahead of own ship in 2.5 miles NCPA. For you required, number 1, SRM, number 2, new DRM, number 3, new BCPA, number 4, TMX, number 5, new SRM, number 6, new time of CPA, number 7, new on course, number 8, new on speed, number 9, target through course, and number 10, target through speed. And now to proceed with our plotting demonstration. So as seen here in your radar transfer plotting sheet, you have your given on course 350 degrees true, on speed 14 knots, RMX is 5 miles, NCPA is 2.5 miles. Target data is written here at the upper right. First observed position time is at 1000 hours, bearing 035, distance 9, followed by the second observed position time, 10:06, the bearing 035 and a distance of 7.5. The last observed position time is at 10:12 hours, bearing 035 and the distance 6 miles. For our required data, SRM, new DRM, new BCPA, TMX, new SRM, new time of CPA, new on course, new on speed, target through course, and the target through speed. So we have all the solutions here already written. The first would be to get the time interval. So all you have to do is subtract the time at R from the time at M. So 1012 minus 1000 hours would give us a time interval of 12 minutes. To begin with our plotting, so on course is set at 350 degrees through. This is your on course, that is 035. On course 350 degrees through. This will be your starting position, point E. Next, to plot the target bearing. So 035 degrees is the target bearing. So 035 is here. Next, for the distance, 9 miles, 7.5, and 6. So measure 9 miles in your scale. by using your compass divider. So that's 9, followed by 7.5. Measure 7.5 in your scale. And measure 6 miles in your scale. Or better yet, since we're using the 12 miles scale, each ring is equivalent to 2 miles interval. So 6 would be here. We want to verify, measure 6. That's it here, that's 6. So this is the first observed position, followed by the second, followed by the third. So label this as R, label this as M. The next process would be we have to bring R on course later on towards here. R, to establish R triangle. So place one side of the triangle at your own course. Place the other one just below to act as your support. And slide it towards R. Next, we have to establish our distance from E to R. So to do this, we have our formula here. Distance from E to R is equivalent or is equal to 0 for our own speed multiplied by our time interval divided by 60. So our own speed is 14 multiplied by the time, that is 12 minutes, divided by 60. If you want to do the rapid plot, place one leg of the triangle here at 60 and the other at 12. So 12 to represent your time interval, 12 minutes. Next, all you have to do is lift your compass divider. Place one leg at 14 to represent your speed, that is 14. So the distance is 2.8. This is 2, this is 3, it's 0.8. It's 2.8. So the distance from E to R is 2.8 nautical miles. Next would be measure 2.8 here in your scale. So measure 2.8 miles. Place it at E and do not fold your compass divider yet. So your distance here is 2.8 will be the same here. And label this as R, and label this as E. So we now have our E to R line. And just erase the excess line. Erase the excess line also here. For the next process would be our RMX is 5 miles. So 5 miles. So all you have to do is measure 5 miles by using your compass divider. Place it in the scale. So this is 5 miles. So this will be your MX or point of execution later on. That's 5 miles. And all you have to do is connect your R M to your MX. And just erase the excess. So the distance for MX is 5 miles. So all you have to do is erase the excess. Okay, to continue with our plotting. To solve for our SRM, we have the formula. SRM is equals to distance from R to M divided by the time interval, that's 12 minutes. So the distance from R to M, since the distance is 9, it is from R and M, it is 6. So 9 minus 6 would give us 3 nautical miles divided by 12 minutes. Without using your calculator, do the rapid cut to determine your SRM. Place one leg at 60 and the other one at 12 to represent your time. That is 12 minutes. Okay, 12 minutes. Next, lift your compass divider and place it at 3 to represent your distance. That's 3. The speed of relative motion would be 15. 15 knots. So SRM is equivalent to 15 knots. Next process would be to solve for our new bearing of CPA. But in order to do this, so we have our RMX, that is 5 miles. This will be our MX here. We have to establish our new CPA, that is 2.5 miles. In order to do this, all you have to do is measure 2.5 by using your compass divider. So measure 2.5 in your corresponding scale. So this is 2.5. And draw an arc. Place one leg at P and draw an arc. So anywhere within this particular area, that's 2.5. Will be our CPA. So to continue with our plotting. So all you have to do is connect MX towards this 2.5 miles radius. This particular area here is 2.5 miles. So this will be our new CPA, that is 2.5. So we have to draw a line from MX towards 2.5 miles arc, just through, and draw a line. This will now be your new RML. Next would be we'll bring this new RML towards the center to determine our new DRM. So our new DRM would be 2, 4, 5 degrees through. The next would be we have to bring this line, your new RML, towards M. Adjust your triangle. See to it when you draw a line, which should be exactly at the center of M. We will be using this side of the triangle later on to form our new force to steer, or force alteration. So we're done with our SRM. We now have our new DRM. To get the new BCPA, new BCPA is equals to new DRM plus 90 degrees. So the new DRM, that is 245 degrees true plus 90 degrees give us new BCPA of 335 degrees true. To check your new BCPA, you may do so by placing one side of the triangle here along your new RML and place the other one that is 90 degrees towards E. Should be towards E. And adjust your angle. This now be your new BCPA, that is 335 degrees. This point here will be your new CPA. The time later on will be your new time CPA. For the next process, the time at mx. So we are required to solve for the time of mx, time at the point of execution here. This is our mx. So the time of mx is required. So to solve for our tmx, given our formula, so your travel time, that is distance from M to mx, the distance from M towards mx, because the time at M is at 10, 1200 hours. So the distance from M to mx, all you have to do is, since the time at M here is at 10, 12, and the distance is 6 nautical miles, whereas our RMX is 5. So 6 minus 5 will obviously be 1. This is 1 mile. So the distance from M to MX is 1 mile. So 1 nautical mile divided by our SRM, that is 15. 15 knots. So by using your compass divider, place one leg at 15. This is 10, this is 15 here. So your speed is 15. Next, the distance, that is 1. So 1 mile. So 1 is here. This is 1 mile. This is 15. And transfer your compass divider here at 60. So the distance is 4 minutes, so 4 miles. So the travel time would be 4 minutes. So the time to cover the target vessel from M to MX would be 4 minutes. That's 4 minutes. To solve for the TMX, time of MX, all you have to do is add your travel time to your time at M. So 10:12 plus 4 minutes would give us a TMX of 1600 hours. So the TMX is 1600 hours. Meaning to say at exactly 10:16, you are to alter your course to starboard. The next process would be, so we're done with our TMX, to solve for the new SRM. We have to solve for the new SRM. Given the formula, new SRM is equals to distance from R1 to M divided by the time interval. But since we do not know the position of R1 here, so in order to establish the position of R1, all you have to do is measure the distance from MX towards your new CPA. So measure this distance, MX towards NCPA. So measure this distance. So this distance will be transferred here at M. Okay, again, measure this distance, MX to NCPA, and transfer the leg point M and draw an arc. And place this in your scale to determine the distance. That's 4.4. So 4.4 miles. So the distance here is 4.4. 4.4 miles. So this point here will now become your R1. This will now be your R1. Distance is 4.4. So we now have our value of the distance from R1 towards M. This is R1 to M. That is 4.4. 4.4 nautical miles divided by the time interval, that is 12 minutes, to solve for our new SRM. So by using your compass divider, place one leg at 60 and the other one at 12 minutes. 12 minutes and 60. Transfer the leg at 4.4. This is 4. This is 5. 4.4 is here. So the speed is 22. Again, place one leg at 60, the other one at 12. transfer it 4.4 that to determine the new SRM. That's 20, 21, 22. So 22 knots. So the new SRM is 22 knots. Next would be to get our new time of CPA. But before we get the new time of CPA here, we have to determine the travel time. That is from MX towards the new CPA. So since the distance is 4.4 from MX towards NCPA, so 4.4 miles divided by your new SRM, that's 22 knots multiplied by 16. So 22, and 4.4. So 22 and 4.4, 22 knots. Distance is 4.4. The travel time from MX towards NCPA would be 12 minutes. So the travel time would be 12 minutes. So this is 10, this is 15, 10, 11, 12. This is 12 minutes. So 12 minutes is the travel time from MX towards NCPA. So all you have to do is just add 12 minutes to your TMX. So our TMX is 1016, 100 hours. So 100 hours plus 12 minutes. Our new time of CPA would be 10, 28. So 10, 2800 hours. The next item would be to get our new on speed and new on course. New on course and new on speed. So in order to do this, since we are to alter course to starboard, so all you have to do is connect E to R1. E towards R1. E to R1. After drawing a line, after connecting E to R1, all you have to do is slide your triangle towards E. So our new on course would be 0, 3, 7 degrees 2. So we have our new on course that is 0, 3, 7 degrees 2. To solve for our new on speed, all you have to do is measure the distance from E towards R1. Measure the distance from E to R1. Two point eight. So that's 2.8. So the distance from E to R1 would be 2.8 miles. So 2.8 nautical miles. So to solve for our new on speed, given the formula, new on speed is equal to distance from E towards R1 divided by the time interval multiplied by 60. So the distance is 2.8 divided by 12 minutes multiplied by 60. So 12 minutes and 2.8. 2.8. So our new on speed would be 14. New on speed would be 14 knots. And to get the target through force and the target through speed, all you have to do is connect E towards M, E to M, to determine the target's true force, E to M, and place the other triangle as support and slide towards the center, towards E. So the target true force would be 282 degrees true. 282 degrees true. And for the last item, the target true speed, all you have to do is measure the distance from E to M. Distance from E towards M. So measure the distance from E towards M. One. And place it near scale. That's 2.2. 2.2 miles. So the distance from E to M is 2.2 miles. So to solve for our target true speed given the formula, target true speed is equal to distance from E to M divided by the time interval multiplied by 60. So 2.2 nautical miles divided by 12 minutes. So 12 minutes so place one leg at 60 and place it at the one having the lead should be placed at 12 to represent your time. So 12 minutes. And all you have to do is lift your compass divider, place it at 2.2. This is 2.1.2. So the target true speed is 10, 11.5. So 11.5 knots. 11.5 knots. So there you have it. That's the process and computation on how to find your method number 2. Method number 1. How to find your method number 1, your course alteration for collision avoidance. So method number 2 will be discussed in a separate video. So I do hope you learned something. Thank you. Please don't forget to like and subscribe. Thank you so much and have a pleasant day.